In this video, I'm going to go over these problems on page 258 out of section 1.7. After I do number 50, I'm actually going to sneak one more example in there that's kind of like number 50, but to me is a little more interesting. So on page 258, to get started here with number 48, the instructions are: find the functions f plus g, f minus g, f times g, and f over g, and then determine the domains for each function. So first off, let's find f plus g of x. Well, that's just the square root of x plus 6 plus the square root of x minus 3. There's nothing to simplify or do anything with there. That's as much as we can do. F minus g, I'm going to end up kind of in the same situation where there's not really anything for me to simplify. I'm just kind of writing it down. There it is. F times g, I have two square root functions multiplied together. Technically, I can at least do something to make it look a little different, because when I multiply square roots, I can imagine taking the square root of the product. And now on the inside of this, I can distribute. I have x squared. Now let's see, that's a 6x minus 3x, so plus 3x minus 18. It's about as much as I can do with that. And then finally, I have f over g of x. All right, so there are my nice, happy functions just found using the algebra rules we went over in class. But now I'm asked to find the respective domains. Well, to do that, I need to know the domain of f and the domain of g. The domain of f is everything to the right of minus 6, because I need x plus 6 to be greater than or equal to 0. The domain of g I need x minus 3 to be greater than or equal to 0. So I add 3 to both sides, and I find out those are the x's to the right of 3. Well, what I remember is that the domain of the first three functions here, 1, 2, 3, are all the same. The domains of f plus g, f minus g, and f times g, all the same, so I'm just going to write them down once. And I like to think about these two little intervals for a minute, just as a little scratch work. So the domain of f, all of the points, that was supposed to be a minus 6. Minus 6 and a positive 3. All right. The domain of f, all of these points. The domain of g, all of these points. And I like thinking about taking those two intervals and smashing them down on top of each other, and wherever they overlap, that's my domain for f plus g, f minus g, and f times g. And I'm ridiculous. I like thinking about that as red and blue make purple. So there it is. If I smash those together, I get this little purple interval here. And so here's my domain just from 3 to infinity. The domain of f over g starts with that, but I have to throw out anywhere where I would be dividing by 0. Looking at the bottom of the fraction, if I was to plug a 3 in, I get 3 minus 3 is 0. So I have to remove the 3. And there's number 48. The four functions and then the domains. Next up, problem number 50. Number 50 looks a lot like that. It gives me two square root functions, so I can think about adding them together. I can think about subtracting them. Multiplying them. And that's where I could actually write things under the same radical. I could simplify that. End up with a minus x squared plus 10x minus 25. And then finally, I could do a little division. All right. The domain of f plus g, f minus g, and f times g. Let's think about a little number line. I know 5 is going to play an important role. The domain of f, I need x minus 5 to be greater than or equal to 0. That's going to be those. For g of x here, I need 5 minus x to be greater than or equal to 0. Add x to both sides, and I get 5 is greater than or equal to x, which I like to think of as x is less than or equal to 5, so it's all of these. And when I imagine the overlap, I find out the overlap is just one single point. The domain of these 1, 2, 3 functions is just the number 5. It's the only number I'm actually allowed to plug into all of them. And that is amazing. I only get 1 point in that domain. I go to find the domain of f over g, and I know it's either this or I have to take a point away. I can't plug 5 in here because I would get 0. There's literally nothing in this domain. We write a symbol for that looks like this. That's not the number 0, that's a symbol for the empty set. I would also accept just you writing the word nothing. There's literally nothing in the domain of f over g. This is not a function. I'm not allowed to plug anything in. All right, well that was number 50, and I told you once I got to 50, I do one like 50. So I'm calling this 50 plus. Just another problem like number 50. Writing the functions down, not particularly interesting. Just going through and doing the arithmetic operations. Nothing to simplify on addition or subtraction of square roots here. F times g, at least I get to distribute. Because I'm multiplying, I can write things under the same radical. And when I multiply all of that out, I end up with minus x squared. Let's see, I'm going to end up with a 9x in the middle, minus 14. And then finally, f divided by g of x. All right, let's find domains. I'm going to think about a little number line here. I think numbers 2 and 7 are going to turn up to be important. The domain of f, if I think about x minus 2 being greater than or equal to 0, it'll have to be the interval over here to the right. If I think about 7 minus x being greater than or equal to 0, it's going to have to be these nice happy values. On this one, when I imagine where they overlap, I get just this closed interval between 2 and 7. So these first 3 functions have the same domain. And it is the values from 2 to 7. And if I want to write down the domain of f over g, I start with that. But then I realize if I plug 7 in, I get 0 on the bottom. So I just get 2, 2, 7. And there's 3 problems all dealing with square roots. I really like this one here, 50 plus. Not in the textbook, but just a problem I thought would be helpful. Next up, we have problem number 62. The instructions are different. We're asked to find 4 different things. Part A, we're asked to find f composed with g of x. In part B, we're asked to find g composed with f of x. And then finally in C and D, we're asked for some function values. F composed with g of 2. And in part D, g composed with f of 2. And we'll talk about two different ways of doing those last parts. But for right now, let's just find our composite functions. Part A, f composed with g of x means f of g of x. My outside function is f, and this is the square root function. Whatever gets plugged into f goes in there, so that's the square root of x plus 2. Part B asks me to find g composed with f. Well, that really means g of f of x. So my outside function now is the x plus 2, so something plus 2, and then the function f gets plugged in there. And I would just call that root x plus 2. F composed with g of 2, well, since I've written this formula down, I could just use it. And by plugging 2 in there, I get 2 plus 2 is 4, the square root of which is 2. Another approach, this is completely done, we're done, we could move on, but if we wanted to do this a different way, I could remember that that's f of g of 2. So I imagine plugging 2 into g, I get 2 plus 2 is 4, and then I plug that into the square root function, so f of 4, because 2 plus 2 is 4, and then that's the square root of 4 is 2, and we get the same thing both ways. And that always has to work. Part D. G composed with f of 2. Well, again, we have a formula here, so I could just plug the 2 in. Root 2 plus 2. I'm not going to round it, not going to do anything with it. That's a nice, happy, exact answer. But I should be able to follow the approach of starting on the inside and working the way out. And again, this is a good way to do it. We're done at this point, but I just want to talk about the other way. Plug 2 into f, and we would get root 2. So g of root 2. Now I get to plug that into the function g, and I get root 2 plus 2. Get the same thing either way, and that always works. Both methods have to work. All right, so that was 62. Next up, we have problem number 68. Problem number 68 has us write down f composed with g and then find its domain. So find f composed with g and then find its domain. All right, well, let's write down the composite function first. All right, the outside function, 5 over something plus 4, plug in the function g. We would never, ever leave a compound fraction. We might have to use this later on, so we're going to simplify it. Easiest way to simplify this is to multiply top and bottom by x. That's the least common denominator of every denominator. Well, it's really easy to find because there's only one of them. And we multiply through. On top we have 5x. On the bottom I have 1 plus 4x. There's my nice, happy composite function. Now we're asked to find its domain. And I like a two-step process where we first find the domain of the function g. Because the domain of f composed with g has to start there. You have to be able to go into the function g. You have to be able to plug all of those x's into that function. All right, next up, I take that particular domain and I remove any values that break this new formula. And all I'm worried about is the bottom being equal to 0. And if I solve that, I'll find that I have to get rid of the x equal to minus 1/4. I've already taken 0 out, now I have to take out minus 1/4. So I'm going to write my final answer down here. Taking out that value at minus 1/4 and the value at 0. So there's my answer to number 68, the composite function and its domain. I always use that two-step process. Next up, number 74. 74 comes with the same instructions to find f composed with g and then its domain. Well, I really like this one because it makes me think. In part A, I'm going to find f composed with g, f of g of x. So the outside function is the squaring function plus 1. G of x goes in there. So I get to simplify this, and I get 3 minus x. But let's write down the domain so I'm not confused about which x's I get to use. I first write down the domain of the inside function. Well, with the square root function, I know the inside has to be larger than 0. All right, so the domain of that inside function, the domain of g, are just all of the x's that are less than or equal to 2. X is less than or equal to 2. Well, when I look at my new formula, nothing's going to break it, so that's my domain. If I wasn't paying attention, just looking at that formula, I might think the domain is all real numbers. But then I remember that the x values have to be able to be put into g, because g is the inside function. It's the first to act. So I always need to go through this two-step process. All right, just one more thing to think about in this video of problems from section 1.7. And those are the problems between 83 and 88, which to me is just one problem with a bunch of parts. All dealing with this graph. We're asked to find some function values, and then we're asked to find two domains from these graphs, using these graphs here. Well, if I think about what f plus g of minus 3 is asking, it's asking for f of minus 3 plus g of minus 3. So I can use my graphs to do that. The blue function is f. So f of minus 3, 1, 2, 3, 1, 2, 3, 4. So this is the point minus 3, 4. So f of minus 3 is the number 4. G of minus 3. Well, I go over to minus 3 and I see where the y-coordinate is on that red function. So I go over to 1, 2, 3, and I get out a 1. 4 plus 1 is 5. And that's all we're doing on these problems, using these graphs to find points and then doing the arithmetic operation. All right, so for g of x, g minus f of minus 2, I have g of minus 2 minus f of minus 2. So again, let's find those y values. G of minus 2 is 3. F of minus 2 is 3. I need to find g first, g of minus 2. And that gives me the value 2 minus f of minus 2. Now that's 3. So my final answer here is minus 1. All right, now I have a f times g of 2 and a g over f of 3. That's going to be f of 2 times g of 2. F of 2 is 1. 1 times g of 2 is minus 1. All right, well, 1 times minus 1, that is minus 1. Finally, I have g over f of 3. G of 3 over f of 3. G of 3, first up, well, g of 3 is 0. All right, f of 3 is minus 3. 0 divided by minus 3 is 0. All right. Two last things to do here in section 1.7. I'm supposed to find the domains of f plus g and f minus g. And we can do that, f plus g and f over g, we can do that the same way we did it in the previous problems. I first need to know the domain of f. Well, very literally, if I think about all of the x's, I can just kind of see that they're these ones, right? Starting at minus 4 and ending at positive 3. literally the domain of f would be from -4 to +3. The domain of g, well, it starts down here, right, all the way at -5. And then it goes all the way to here, and let's see this, 1, 2, 3, 4, 5. Well, the domain of f plus g is where those overlap. So that's the interval from 4 to 3. The domain of f over g is that same interval throwing out anywhere where the bottom function is equal to 0. Well, if I look at it, the bottom function is 0 at both endpoints, so I have to take them both out. And I just get the interval from 4 to 3, but this time it's open. All right, so that's just a few problems using the algebra of functions.